All right, today we are going to be discussing the periodic table of elements. So you guys have seen this poster in my room since day one, and right now we're actually going to learn about the properties and the organizations. The periodic table organizes elements in a particular way. So there's grids and rows and columns, and they're all organized by the same thing so that you can actually gather information about the element based on where it is. So based on where it is on the periodic table, that tells you what physical and chemical properties it's going to have, and then it also lets you know what it will bond with and what it won't do. We have 118 known elements, and this is going to help you figure out the basic information. Each element is going to have a square on the periodic table. Now, I don't want you to get in the habit of saying the top number and the bottom number because it's different on every periodic table that you will see. I want you to get used to saying the larger number and the smaller number in terms of the actual number itself. So 1 is smaller than 1.0007. Hydrogen is a particularly bad example because its mass is 1 and its atomic number is 1. Elements on the periodic table are organized according to their atomic number. Usually it's on the top, but that's not a guarantee. And the atomic number means how many protons it has. Hydrogen is the first element. It has 1 proton. And you will see the periodic table gets organized by increasing atomic number. No two elements can have the same atomic number. They can, however, have the same number of neutrons. Usually this is what you'll see in a periodic table square. So you'll see the atomic number, the atomic symbol, the atomic mass. So H is the atomic symbol for hydrogen. You'll see the name of that element as well. The number of valence electrons. So if you look in the bottom right corner, you'll see a number 1. That means that hydrogen has 1 valence electron. A valence electron is the electron that is on the outermost ring. For hydrogen, it has 1 electron total. But for an element like sodium, Na, sodium has 11 electrons, but it will say 1 valence electron because it only has 1 electron on its outer shell. The atomic number refers to how many protons an atom of that element has. That is how you identify an element. It is by the number of protons, which is usually the same as the number of electrons, only if it is stable. The atomic mass is how much the atom weighs. So the atomic mass is the neutrons plus the protons. So if I have 2 neutrons and I have 2 protons, like helium does, the mass would be 4. It only has 2 protons here if you see in red, so that means it has an atomic number of 2. And helium, He, is actually our second element on the periodic table. The symbols you will see, every element has a unique symbol, and it is either 1 or 2 letters. A single capital letter or a capital letter with a lowercase letter. If you see something and you see 2 capitals next to each other, that's going to be 2 different elements combined. The most common mistake that I see, and I got it all year last year, so I want to cut it out, is when you see chlorine. Chlorine is Cl, and a lot of people think that says Ci. No. If you see 2 letters next to each other and you think it's going to be an I, it has to be uppercase. So Cl, when you see it, is Cl for chlorine, not carbon bonded with iodine. Here are some common elements that you should know. If you're watching this at home, go ahead and pause this video and then write these down. Valence electrons. So we touched on this. Valence electrons are the number of electrons that are outside on the outermost shell. Valence electrons are only the outermost shell. So you can have 4 shells and it's only the ones on that 4th shell. And the reason that these are so important is because they're the electrons that actually move in bonding. Beyond that, elements are grouped into families, which are vertical columns, and then periods, which are the horizontal rows. Elements in families, so if they're in vertical columns together, these will have the same properties. They'll be the same. That's why they're in a family together. And then here, the periods are horizontal rows. The periods do not have the same properties. So if everything in row 2 here, these are not the same. But everything in column 1 will act the same. If you're writing this at home, or if you're watching this at home, go ahead and pause this and then write down this slide. The thing that you need to know about families is that every single element in a family has the same number of valence electrons. So we're just going to go through. Hydrogen is its own family. It does not have a family. It is a little orphan element. Then this is your group 1, group 2A, your transition metals, group 3A, 4A, 5A, 6A, your halogens, and your noble gases. So hydrogen sits on top of family A1 or 1A, but it is not a member. It is its own. It's a gas. It has 1 proton and 1 electron, and it only needs 2 electrons to fill up its valence shell. So a full octet, we normally go for 8 electrons, but hydrogen only has 1 shell, so you're only going for 2. Group 1A are your alkali metals. They're the first column. They're the most reactive metals. They react violently with water, and they're never found free. They're always bonded with another element. So you will never just find a rock of sodium metal sitting by itself. It will be bonded because it reacts in the air. It ignites in water and it ignites in air. So for the rest of this, we're going to be describing elements according to their reactivity, and that means how easily they bond with other elements. So if they are extremely reactive, that means they bond super easily. If they are not reactive at all, that means they do not bond. In order to be reactive, you have to have an incomplete valence shell, which means you have less than 8 electrons, except for helium. Helium and hydrogen only want 2. So helium has 2 electrons, so it does not react. And then atoms will keep bonding until this is complete. So atoms with less than 4 will lose those 4. Atoms with 5, 6, 7, and 8, those will gain them during bonding. So for an example, sodium has 1 valence electron. So on the third shell, there's only 1 electron here. Chlorine has 1, 2, 3, 4, 5, 6, 7. So chlorine needs 1 to get to 8, and sodium needs to lose 1 to have a full shell on ring 2. So sodium is going to lose 1 electron, and chlorine is going to gain it here. Now sodium loses this whole shell, and chlorine has a full shell. Alkaline earth metals are your second group, and they're very similar to alkaline metals. They're never found uncombined. They have 2 valence electrons, that's why they're group 2A, and they have magnesium, calcium, and a couple others. Your transition metals are going to be groups 1 through 11B, and we lump these all together because they don't necessarily follow all of the rules that we want them to. So the transition metals sort of mess up the beauty that is the periodic table. But you probably know them. You know copper and zinc and nickel and gold and silver. They're good conductors of heat and electricity. So they still behave like metals, but they don't match everyone else. Transition metals are normally really bright and can be often used in paints. They also have 1 or 2 valence electrons, but it varies. So you can have multiple forms of each of the transition metal. So they're similar to one another and to other metals, but they don't fit in with the rest of the families. And they often combined with oxygen to form something called oxides. So transition metals are a huge group, but they don't fit in, they don't have the same properties as alkali metals, they don't have the same properties as alkaline earth metals, so we just call them the transition metals. The next group, 3A, is the boron family. Boron is that top row, and it's in group 3A, which means it has 3 valence electrons. The rest of these are metals except for boron, which is a metalloid, and it also contains aluminum. The carbon family is group 4A, and you guessed it, there's 4 valence electrons because it is in group 4A. The next is the nitrogen family, again the top element in this bright green group. It has nonmetals, metalloids, and metals, and everything has 5 valence electrons. So they tend to share electrons when they bond because it's mostly nonmetals. The oxygen family, these are also called chalcogens. Everything in this group has 6 valence electrons, and they share electrons in forming compounds. All of these are nonmetals. The halogen family, everything in here is also a nonmetal. It's the second to last group, group 7A. So they have 7 valence electrons. Halogen atoms only need 1 electron to fill their outermost energy level, so they react with alkali metals because alkali metals have 1 electron to lose. And the last group, these are completely unreactive, and they're your noble gases. They're colorless. They do not react at all because they have 8 valence electrons. So their outermost energy level is completely full. So they're not going to combine with anything. And the last one are on the bottom are rare earth elements. There are 30 of them. It's the lanthanide and actinide series. One element of the series in lanthanides, and most of them in actinides, are synthetic, which means that they are man-made. And the last thing you need to know is this man here. This is Dmitry Mendeleev, and he is the first creator of an accepted periodic table. So he grouped elements according to their atomic mass and found that those families had similar properties. Then he left blank spaces because he could predict from their properties that new elements would occur, which is exactly what you are going to do in this card sort activity. If you have any questions, please feel free to ask me.